about problem solving and data analytics. So this is a unit 3 of SAT preparation, right? So this is problem solving and data analytics. So as part of that, the other thing that we'll be learning, one is ratios, rates and proportions. Next thing is unit conversion, like converting from pins to quarts to gallon, likewise from inch to foot to yards. Then we'll learn about the percentages. So most of the things you would be knowing already. We're just going to do a recap of it. Right? Then the next thing is center, spread and shapes. Shape of distribution. So when you say center, you're talking about things like mean, median, mode that we always talk. When you talk about spread, that is where you talk about the range, the variance and the standard deviation. Then we will talk about data representation, scatter plots and linear and exponential growth, and also probabilities to some extent. So let's start with the first part, which is ratio, rates and proportions. So ratio, rates and proportion. When you talk about ratio and when you talk about proportion, what is the difference? Okay. So when you talk about ratio is it's more of a way to compare quantities. Okay. So let's say you're comparing 3 with 5. Okay. So 3 ratio is a way to say compare 3 against 5. Okay. Or 5 against 3. So when you're saying 3 against 5, it's a smaller number against a larger number. So it will be a smaller portion of it or subset of this. When you're talking about this is like a superset. So you are, let's say, if you look at the analogy, you're talking about 1 month's salary versus 3 months' salary. So 1 month's salary versus 3 months' salary. This is 3 months' salary versus 1 month's salary. This is how you depict ratios. Now, so ratio you can always, let's say, so we are starting with ratio first, okay? So let's say you have 3 oranges and 2 apples in a basket, okay? There's one type of ratio which is called part to part. So this is one part, this is one part, right? So you can say this is apple, this is one part of the basket, and this is oranges. This is another part of the basket. So you'll say apple to oranges ratio is 3:2. So for every 3 apples, there are 2 oranges. So this is one part versus against second part. So this is called part to part. Second one is called part to whole. So if you look at whole, meaning the whole basket. So apple is 3 out of 5 fruits that you have in the basket. So this is the whole number of fruits in that basket against which you are comparing. Okay. So let's say if we look at the age of all the family members. Okay. So one child's ratio against another child's, one child's age against another child's age is a ratio which is part to part. One child's age against the summation of age of all the family members is a part to whole. So basically whole is the total thing against which you are comparing. So this is where you end up calculating the percentage. Okay, 3 out of 5. 3 apple out of 5 is 3 by 5 is equal to 60%. How we calculate that you must be knowing. Okay, so there are 2 types. One is called part to part and part to whole. You will probably not end up dealing with these terminologies. I also had not dealt with the terminology as such, but I knew how to derive the ratio. This is just just something that we need to know if in exam somebody says, okay, what is the part to whole ratio or part to part ratio? So part to part is we are comparing one part with another part and finding the ratio. When you are comparing one part with the whole, the superset, that is when you say part to whole. Okay. So now, in ratio is nothing but comparing one number against another number. Now when you look at one group of things, one thing against other thing in that same group, that is part to part. One thing against the whole in that group is part to whole. So you can look at part to part as a comparison of two students' marks in a particular subject. Okay. And part two, that is part to part. Part to whole will be comparison of one person's marks versus the sum of the marks secured by all the students in that class. Okay. So that is part to whole. Now there is another thing that is called equivalent ratio. So if you are writing 3 by 5, it's another way of writing ratio. You can also read this as 3 by 5. This is also same thing. Okay. This is in form of a ratio. This is form of a fraction, but both mean the same thing. Okay. Now there is another term called equivalent ratio. 6 by 10 equals 3 into 2, 5 into 2, tic-tac-toe. 6 by 10 is equal to 3 by 5. This is called equivalent ratio. It is just simplifying the ratio into more simplified form. Okay. Similarly, if you have a mixed number like this, you can also convert this into a equivalent ratio by simplifying this as a fraction. 6 3 18 plus 220 by 3. This is also equivalent ratio. It's the same thing. I mean, you're just putting it in different form. So we learned about the ratio. Now let's look at proportion. Okay, you are trying to make cake, and you have been told that you have to mix 3 cups of flour with 1 cup of sugar. So if you are making a small cake, you will add 3 cups of flour with 1 cup of sugar. If you want to make a cake with 12 cups of flour, how many cups of sugar you would need? It is nothing but the equivalent ratio. So you are saying that equivalent ratio 3:1 equals to 12 is to x. I don't know what is x. So it's like a ratio in which things are to be mixed, and one equivalent ratio, and you have to find the other one. Okay. So simple example is, okay, if says you are making cake. While making cake, you need 3 cups of flour. For every 3 cups of flour, you need 1 cup of sugar. If you are making a bigger cake with 6 cups of flour, you would need 2 cups of sugar. If you are making cup with 9 cups of flour, you would need 3 cups of sugar. This is nothing but this depicts the proportion. That's why we say we have to add things in the right proportion, meaning one thing compared to other substance in a recipe or in a composition. Let's say if the Frisco school district says that you cannot have more than 60% boys in a class, meaning at most you can have 60% boys in the class. That means remaining 40% will be girls. So that means if there is a class of 100, you'll have 60 boys, at most 60 boys and 40 girls. Okay. If you have a class of 50, you will have 30 boys and 20 girls. So this is what is, it's a proportion. You just know the relationship between the two quantities, and based on the volume you will expand or shrink. So that is what is proportion. So now
what you know is at most you can have 60% boys in the class, meaning boy to girl ratio is this. This is another way of representing a proportion. It just tells you the relationship and equation between the two things. Like we looked at 3 cups of flour against 1 cup of this thing. So this is a relationship that cannot change. If you're going to mess with it, you will either break the rule put by Frisco School District or you will mess with the cake. So this is what is called proportion. So if you look at the definition of it, it's right. It says it's just a relationship between two ingredients, two parts of a same thing. Okay. So mathematically, ratio proportion looks similar, right? Only difference being proportion gives you the relationship between two things. Okay. Okay. So if somebody says that to ensure diversity in the class, you can, or let's take the visa thing, the green card thing as an example. What they say is you can have certain number of person from each country. So every country maximum this many visa or green card can be given every year. If there are 2 countries, you will give 2810 into 2. If there are 3 countries, they will give this many. So it sets the precedence of the rule, saying how these things can be related. Okay. Cup and sugar and flour ratio, boy to girl ratio, even AP exams. Let's say every class can take maximum, or every student can take up to 3 AP classes. So depending on the number of students you have in the class, you can define how many AP classes are taken, right? So this is a relationship. So ratio and proportion, these two clear. Ratio part to whole, part to part, clear. Okay, now let's look at okay. Now rate is nothing but, let's look at 500 grams and 2 kilograms. This unit or the quotient of this number is what defines the rates here. So now this sets the precedence. Now let's say I walk 5 miles per day, per hour. This unit of distance is compared against another unit of time. You say this is the rate at which I walk. The plane flies at 600 miles per hour. This is the rate. I study 30 minutes per day. This is the rate at which I'm studying. I solve 20 sums per hour. This is my rate at which I am solving sums. So this is what rate is. Clear? So rate, ratio and proportion. Clear? Conceptually? Any doubt? No. Okay. Now let's look at some interesting unit conversions. Now any number that you look at, this number, seconds, minutes, these things
help you quantify.
I mean, you know the number, but the actual weight or actual meaning of that number when you use that against a unit, right? 200, what 200? 200 rupees, 200 milligrams, 200 psi of pressure, 200 ounce of something, or 200 liters of gas. So when you use that with a measurement, based on the unit that you use, you can interpret the volume or the weight or anything which signifies that, right? So in when we are talking about unit conversion, we are looking at different units and try drawing the relationship. Millimeter, you must be knowing this, right? 10 millimeter equal to 1 centimeter. 10 centimeter equals 1 decimeter. 10 decimeter, 1 meter, right? Then decahectokilometer, millicentidecimeter, decahectokilometer. That is the formula that we had learned during the childhood. So 10 millimeter, millicenti, 10 centimeter is 1 decimeter, 10 decimeter is 1 meter. Then comes 10 meter equal to 1 decameter. I don't think you guys learned this one, decahectokilometer. I have not seen you guys learning it. But only thing that you might want to relate is like all these are, let's say in terms of distance, right? Millimeter to meter. This much you must be knowing. Then you must be knowing that 100 meter, anything, 1000 of anything makes it kilo, right? 1000 meter is 1 kilometer. Now look at some other units that we deal with here. What do you see in this one? So we use gas, right? I keep on saying I fill 16 gallons today. I filled 8 gallons today. I just took 2 gallons today. How is that gallon related to other units? Right? So 2 pints equals 1 quarts. Okay. 4 quarts is 1 gallon. This you might want to remember because these are the usable things, right? So say get me 2 pints of something. If you're talking about 1 gallon, you would have seen that gallon container we have. This 1 gallon container. 1/4 of that is a quart. 4 quarts. So like $1 is 4 quarters. 1 gallon is 4 quarts. 1/4 of a gallon is 1 quart. And then 2 pints makes it 1 quart. So 1/8 of a gallon is 1 pint. I mean, just to remember that. And these are the things that you have to remember. I mean, there's no other way. So when you, if you want to know how much my car takes as a gas, right? It has a capacity of 16 gallons. Mom's car has 12 gallons. So that gives you an idea about why do we use gallon and what is the significance of that. Similarly, okay, we all use scale, right? We measure in centimeter and we measure in inches, right? You always keep saying that my height is 5 feet 5 inches, right? That is your height. First of all, feet, or singular term is foot. 1 foot is equals to how many inches? 12. So you know this. Now, in the scale that you would have used, you would have seen that like 12 inches, and then here you would have seen probably 30 centimeters. You should look at the scale that we use, right, for drawing lines and all. There's a relationship between inch and centimeter. So 1 inch equals 2.54 or 51. 54 centimeters. Yeah. Okay. So these are the conversions that you would just need to remember. That's all. So inch to centimeter conversion, because this is the most relatable thing, right? And we talk about height, we talk about distance. This is 2 feet long, this is 5 feet long. If you convert that into centimeter, you just need to know that 1 inch is 2.54 centimeter, and then 12 inches makes 1 foot. Okay. And then 3 feet equals 1 yard. So inch to centimeter, 1 inch equals 2.54 centimeter, 12 inches 1 foot, 3 feet 1 yard. This is one conversion that you have to remember. And second one is pints to quarts to gallon. So 1/4 of a gallon is a quart. Sounds analogous to quarter, right? 1/4 of a gallon is a quart, and half of a quart is pint. Okay, that's all about the conversion. And then some of the basic things that you would have learned before. If you're talking about ice cube, okay, which is 1 centimeter, 1 centimeter in length, 1 centimeter in width, or 1 centimeter length, 1 centimeter width, 1 centimeter in height. 1 centimeter, so the volume will be 1 centimeter into 1 centimeter into 1 centimeter, right? Height of a cube, volume of a cube is length into width into height, or volume of any cuboid or cube. You know the difference between cube and cuboid, right? Cube is where you have all the sides are same length. Cuboid is where it's a rectangle with some height. So length to width into height. Okay. So the volume of a cube is length into width into height. So 1 into 1 into 1. Why I'm telling this is because this makes it 1 into 1 into 1 is 1 into centimeter to centimeter to centimeter. So it's something being multiplied with itself 3 times. 1 cubic centimeter. Okay. So 1 cubic centimeter, this is what relates to 1 milliliter. This is another thing that you would have to remember. So in this whole chapter, okay, chapter 2 about unit conversion, 3 things that you would need to remember. First is gallon to quart to pint. 1/4 of gallon, that is a quart. Half of a quart is a pint. Second conversion is centimeter to inch. 1 inch equals 2.54 centimeter, and 12 inches equal to 1 foot. 3 feet equal to 1 yard. That's the conversion. And third thing is, whatever is 1 cubic centimeter, 1 cubic centimeter is what is called 1 liter. 1 milliliter. Okay. Okay. So you will be knowing 1000 milliliter equal to 1 liter. Right? So like we learned, millimeter, centimeter, decimeter, meter. So 1000 of millimeter is 1 meter. 1000 of milliliter is 1 liter. So milli into 1000 takes the milli out. Millimeter, 1000 millimeter equal to 1 meter. So when you multiply 1000 with a milli, that takes the milli out. It becomes meter. Okay. 1000 milliliter is equal to 1 liter. So 1000 of something, some milli takes the milli out. So you can kill milli by 1000. If you multiply that by 1000, the milli is gone. Okay. Milliliter, in terms of liter, in terms of meter, in terms of gram. 1000 milligrams equal to 1 gram. These are all relatable. Okay. So far clear. Then comes
percentages.
So percentages will not touch upon. Okay.
I think percentages you know. Percentage means per 100. Simple.
20%. 20 by 100.
20% of something.
40% of,
Let's say you're saving.
okay. Somebody says give 40% of your saving
To your younger sister.
your saving to your younger sister.
Now, what will you do? 40%. How much you have to give?
Okay, 40%. 40% always means this. 40% of my saving. 40% of my saving. What is my saving? If I have $200, I have to give $80.
40% or 30%. Let's say somebody says, I have to give
12% of my salary.
as taxes.
Let's say if my salary is 5,000, I'll have to give 12%. 12 per. This is per cent.
Cent stands for 100. This is how you do it. Clear, right? This one should be very simple.
Now the only thing that you might have to think is, somebody says,
A number is what percentage of something else?
a number is what percentage of something else. Let's assume this is Z percentage, okay? So let's say X is Z percentage of Y.
I'm just saying the English sentence, okay? Nothing cryptic here so far.
You have to find out X is what percentage of
Other number. Let's say people say your age is what percentage of your dad's age.
Okay, let's say you're 15, your dad is 45. Your age is what percentage of your dad's age? Okay, so you know X, your age is what percentage of your dad's age?
I'm just putting that in the equation here. Now,
Let's look at this.
who has come now? देख रहा हूँ. इसमें देखो.
So let's say we are trying to find X is what percentage of Y, or what, how do we calculate percentage? Y is number, Y is Z percent equal to X. If I have to find out certain percentage of a number,
This is how I find it out.
Y, so let's say here Y is your dad's age, right? What percentage of your dad's age is
Your age. Okay.
here? Let's put the values here. Y is your dad's age, 45 years. I'm hiding 2 years here.
Okay.
What percentage? I don't know what is the percentage.
Okay.
Your dad's some percentage is your age.
Okay.
So I have to find out what is value of Z.
So again, going back, making it simple. If you have to find out a percentage of any number,
10% of 200. How do you find it out? You write 200. Or let's write it like English. 10% of
is always into. Yeah.
of 200.
Simple.
10% of 200, you'll always write this as 200, 10 by 100. 15% of 200, you'll write this 15 by 100 into 200.
Simple. So so far?
So your dad's certain percentage, your dad's age, certain percentage of your dad's age is your age. I'm just putting that in the equation, okay? So if I have to find out Z, what is the percentage? So I will put everything on one side. So Z remains here, everything goes that side. So this guy goes here, this guy goes here. So 15 into 100 by 45. Clear? That makes it 33%. I'm not interested in that. So here what I'm trying to say is, this is a number. What your age is what percentage of your dad's age. So the equation is always this way. Whatever we did so far, this is how you can interpret this. Your age is what percentage of your dad's age. The number which is to be derived as a percentage of something else. This is how you will do it. I just showed you how do we write that formula, right? So whichever number you want to find out, what is that guy's percentage against another number, you'll divide that by number and multiply by 100. So in percentage, there are only two formulas that you need to remember. One is X percentage of Y equals Y X percent of Y. This is the formula. What percentage is X? Percentage is X of Y. Okay? Meaning a number is what percentage of some other number. That equation will be whatever you are trying to find, whatever is the number for which you are trying to derive the percentage against that other number multiplied by 100. This will be your percentage. These are the only two formulas that you have to remember. And again, this is nothing but English. Percent means per 100. X percent of something. X by 100 into that number. When you have to find out what is the percent of certain number against another number, use that number, divide that by number against which you are trying to derive and multiply by 100. That's it. Clear? So this is all that you need to know about percentage. Now let's look at center, spread and shape of distribution. Center. Okay. Now center, spread and shape of distribution. Okay. So these are more scientific methods to find out averages. Okay. So when you say center of something which is in the middle, something that is kind of average, something that is not an outlier, something in the middle. Let's say if in your class there are 10 kids, everybody is 15 to 16 years, there's one kid who is 28 years, let's assume. Then 28 is the outlier, which will kind of mess up with the whole average. But in general, that doesn't happen. So when you talk about average, it gives you when you talk about a center, it's talking about, let's say you have these 5-6 data points, okay? Center is nothing but it takes everything together, derives a number which is closer to almost all the numbers. That's how you can calculate it. So there are three ways of doing it. There are three mathematical terminologies used. One is mean. Other is called median. And third is called mode. This is what I keep telling you guys, right? Mean, median, mode. Do you know what is mean? Huh? You know mean, right? It's simply average, as simple as that. Sum of everything divided by the count. That's it. Median. That's a middle number. How you derive? Let's say you have 1, 4, 2, 9, 6, 11. Okay? You have these numbers. You have to find out the mean. Very simple. Add them together, divide by number of numbers, right? So I'll add all this together, divide by 6. That'll be your mean. Simple. Median, that is when a bit of work comes into play. What you have to do is, you have to sort them in ascending order. So how will you put this group? 1, 2, 4, 6, 9, 11. Right? Now look at how many numbers you have. 3 plus 3 is 6. You have to find the middle number here. There is no middle number because it's an even number. Number of even, even, it's a group of total even numbers. Okay. So what you have to do is divide that into two groups. Okay. Take the two middle ones. Okay. 4 and 6. Average this. This will be 5. This is your median. If you are talking about 4, 1, 3, 9, 6 as a number, then what will be the median? Same thing. You'll have to arrange them in ascending order. 4, 6, 9. Pick up the middle number. Here it's easy. To this side, to this side. This is the middle number. This is your mean. This is your median. Okay. So this is another method of finding you something which is in the middle. Okay. The mean is average, median is helping you find a middle number actually in this whole thing, which may or may not be same as your mean mathematically. But this is how you derive the median. Okay. Now, what is mode? Mode is nothing but the number which is occurring for the maximum number of times in a group. Okay, let's say you're talking about age of kids in nursery school. Okay, there are 6 kids in that school. Okay, this is the age. Which number is occurring for the maximum number of times? This is 2 times. This is 1 is 3 times. 2 is 1 times. 4 and 6 also 1 time. This is the mode. This tells what is the probability of some number. Now, if you have to add the 7th number, what is the probability of a number being one among these? Okay. So if you are looking at a group of 6, okay, you have gotten 3 ones. If you add the 7th student in that group, the likelihood of 1 is highest. Not clear?
No.
So mode is nothing but it tells you the most probable number if you are adding something to an existing group. Okay, following the similar pattern. So this is mean, median, mode. Okay, so this is and mean is also called the arithmetic mean because that's the average part, right? Clear? Are you able to relate or you're not able to relate? Huh? Okay. No, I'm just going one by one so that there's no concept left out, and when you do that unit test, you are able to. Okay. Then spread part you're clear. Spread, you talk about range. So if you're talking about kids from 20 to boys from in the age group of 20 to 30, maximum is 30, minimum is 20. That is the range. This is the range we are talking about. I'll not repeat that. Okay. So it's mostly talked with respect to a group of numbers. You pick the highest number and the lowest number. That is your range, right? If you look at temperature for last 1 month, your temperature is going to be in the range of 25 degrees Fahrenheit to 45 degrees for the month of January. Okay, that is the range. Now we talk about variance. What is variance? So let's say, what is that?
The distance between the data from the average.
Okay. So what is the mean of this guy? What is the mean of these 4 numbers? 150 by 4. Probably 4 3. This is the mean. Now variance you'll have to just remember this formula, because this is found by, take this mean, 5 minus 20 square of this plus 37.5 minus 30 square of it plus 37.5. It's the other way around. 30 minus 37.5, 20 minus this plus, okay, let's repeat this. 60 minus 37.5 square of it plus 40 minus 37.5 square of it plus these two numbers also, divide by 4.
So this is the average of squares of difference. Okay. So this just tells you,
if you look at this one, this tells you if every number is
similar, right? Let's say every number was 30.
this would have been 0.
Then it says the variance within the group is 0.
If some numbers are very big,
Then the variance is going to be more, right?
and this is a pre-stage
To derive standard deviation. So standard deviation is a term that helps you find out what is the variance within the numbers. Let's say if you're talking about temperature for a month, let's say February, and there's a lot of fluctuation in that month. So the average, what happened? So average of the difference of that number will give you that, okay, there's too much of fluctuation in the month of February, the temperature, that means kids might fall sick. So standard deviation is something, it's a mathematical way to find out if things are remaining horizontal, or if it's changing too much upward, or if it's going downward. Okay, so if the standard deviation comes negative, that means things are changing drastically downward. If it's changing, coming very high upward.
So standard deviation is square root of variance.
So in this chapter, if you look at what are the things that we learned mean, median, mode, that you already knew. Then we are looking at the spread, where we talk about the range, the variance, and the standard deviation. These are 3 things that we learned. Okay. That's pretty much in this one. Okay, let's do one more chapter and then we'll probably pause it here. Okay. So let's look at data representation as the next chapter.
Data representation. So basically, now if you look at numbers, right, one part is calculation.
Second thing is, how do you represent the data to make meaningful decision out of it? Okay. So that is how the statistical analysis or data representation came into play. Let's say
You want to
talk about, let's say every country does population counting, right?
let's take US as an example. Let's say in 1991 the population was, I'm just making it up, okay, 300 million. Okay, when they did that in 2001, it came to 350 million. Okay, then 2011 when they did, let's say it came to 290 million.
Just look at this data. This looks boring actually.
When you look at a chart like this is where you have 100, 200, 300, 400. So every line here represents 100 million. Okay, this is 200 million. This is 300 million. This is 400 million. So let's say 1991. This is 1991, 2001, 2011. Okay, so let's say this was 200. Then this became 300. Okay, and then
So here, by looking at this chart, it gives you a more intuitive view of the data. That's why we we came across these statistical analysis tools or the charts or the graphs. Okay,
So one is, this is called bar chart, where you're representing data in a bar form.
you know about this, right? Do you know what is a histogram?
Mm-hmm.
Okay, so what is the difference between a regular bar chart and a histogram?
It shows, histograms are like, they show the frequency of
Mm-hmm.
the data, while bar graphs only show the
Hmm.
So histogram, there's no big difference between bar chart and histogram. Only thing is, histogram, you will see that it talks about a contiguous range. Okay, so let's say if I have to, let's say, represent bar chart, you saw, right? We have a two-dimensional view. On one dimension we put a number which shows the quantity, and other dimension we put a reference point. Now if you look at histogram, okay, let's say age of kids in your grade, okay, 14 to 16 years, 16 to 17 years, okay, and then above 17 years, okay. So this mostly, it's you're depicting a range here on the x-axis. So let's say if you have 12 kids who are between 14 to 16 years age, 15 kids between 16 to 17 years age, okay, and then other 30 kids who are about 17. So bar chart, only difference being between bar chart and histogram, you'll see that on the x-axis you're talking about a range. So it says, okay, scores by student between 30 to 40, 25 students, scores in a particular subject between 40 to 80, this many students, scores in a particular subject above 80, this many students. So this is when we are representing the range here instead of just a horizontal axis. And then this, if this range is bigger, this will be bigger. In the histogram, you don't need to have all the ranges of equal size, so you can give a two-dimensional view. Where did this go? So you can have a histogram which says kids from 12 to 14 year age and 14 to 20 year age. So you can have one bar this thick because you chose a bigger range, and another bar this thick because you chose a smaller range. That's the only difference. Okay. Now dot plots. Do you know what is dot plot?
Mm-hmm.
I will not talk about it. Okay. Time taken by students to reach the school by walking. Okay. So let's say there are 5 students who reach in 4 minutes. Sorry, 4 minutes here. Some students 6 minutes. So when you have to represent a count, a recurring count or performance of a certain group of people, that is when you use dot charts. Not going into details. And then line graph, again, line graph is where you show a change with time. This example that we took, right? 1991, 2001 and 2011. You can also represent this as a, let's say this is 300, 200, 300 and this is 350. So you can say, in 1991 it was 300 million here. It went to 350 million and then it come to 290. This is nothing but a line chart.